Good morning, Junior 4. We are going to complete our first lesson, measuring tools. Now we are going to talk about the volume. Okay, so don't forget that the volume is the space occupied by an object. Now we are going to know the measuring tool of volume and also its units. Let's start. The measuring tools or tool for volume is measured by, don't forget that measured by means I need that tool. So volume is measured by a tool called graduated cylinder, like this one. I use this tool, which is called graduated cylinder, to measure the volume of an object. We took before that matter exists in three states: solid, liquid, or gas. Okay, so we have measuring units for volume according to its state. We have volume of liquids are measured in liter or milliliter. Volume of solids are measured in cubic meter or cubic centimeter. So we have different units according to the state. Could be liquid or solid. For liquids, liter, milliliter. For solids, cubic meter or cubic centimeter. You have to know that 1 liter equals 1,000 milliliters. It's a rule. And also 1 liter equals 1,000 cubic centimeters. Again, we can have a question. I ask a question, for example, 3 liters will equal to 3,000 milliliters. Did you get it? Okay, so let's recap again. We took the tool for volume, where I used to measure the volume by graduated cylinder. Units, I have units for liquids and units for solid. Meter, cubic meter or cubic centimeter. So how can we estimate or measure the volume of solid objects? For liquids, I can use only the graduated cylinder. I can put or pour some water in it and record the number. For example, here I have the number is 30 milliliters. What about for the volume of solid objects? We have two ways. If the solid is a regular solid object or if the solid is an irregular solid object. For irregular, like what? Like this box or this cuboid. Okay, it has this cuboid has the same size. This side like this one like this one, and this one. And I can also measure its dimensions by using the ruler. So it's a regular shape. I can use the ruler to measure its dimensions. Okay. What about irregular shape like this one? This stone or this toy, can I use their dimensions by using the ruler? No, I can't use them by using the ruler. So I call them irregular shape. Let's start with the regular solid, like this box. For example, here, before I measure the volume of this box, I have to know three numbers. I have to know the length, this straight line called the length. Number 2, I have to measure its width, this straight line called width. And also the last one, I have to measure its height, this straight line called height. Okay, so I have three numbers: length, width, and height. So to get or to measure or calculate the volume of this box or a regular shape or a regular solid, I will multiply length times width times height. For example, here if the length equals 5 centimeters, okay, and its width equal, I measured it centimeters and its height equals to 3 centimeters. Okay? Well, then what I have to substitute the length, and I write under it or below it 5 centimeters. Below the width, I write 2 centimeters, the number beside it. Below the height, I write 3 centimeters. So again, this is a rule. The volume of the box is equal to the length, the width, the length times width times height. So 5 centimeters times 2 centimeters times 3 centimeters, it will equal to 30. 30 what? Can I write 30 and stop? No, I can't write 30 and stop. I have to define this number or give it the right measuring unit. Here, centimeter times centimeter times centimeter, it will give me a cubic centimeter. As we took before, a measuring unit for volume of solids is a cubic centimeter. So I have to write the right measuring unit. If I didn't write the measuring unit, you will count a mistake. It's wrong. You have to write the measuring unit. Okay? Let's answer another question. In your school book, page 8, number 5. Read with me, what is the volume of a book whose length is equal to 8 centimeters? I will write the given here. The length is equal to 8 centimeters. Okay? Its width is half its length. What's meant by width is half its length? So I have to get the width. Width equal 8, the length divided by 2. It will equal 4 centimeters. And its height is 2 centimeters. Height equal to 2 centimeters. And I have to write the rule and substitute in it. Volume of the book will equal to, I have to write the rule first, length times width times height. So below the length I will write 8. Below the width I will write 4. And below the height I will write 2. 8 times 4 times 2 will equal to 64. Can I stop? No, I can't stop like this. I have to write the measuring unit. So centimeter, the measuring unit of volume will be cubic centimeter. Now we are going to measure the volume of an irregular solid like this stone. Can I measure the length or width or height of this stone? No, I can't. So I can't measure its volume using this rule. I'm going to use a different rule or a different way. I'm going to use this graduated cylinder, okay, to measure the volume of the stone. First, I'm going to pour some water in the graduated cylinder. Okay, like this. Can you see the number? Okay, it's 30. So I'm going to record the first volume, the volume of water, and call it V1. So V1 is volume of water only. Okay. Then I'm going to put the stone inside. Then I'm going to put the stone inside the cylinder. Okay, I'm going to put it now. can you see, can you observe that the level of water rises up? Right? It raised to 30, right? 35 cubic centimeter. It raised to 35 cubic centimeter. Okay, so this volume, is it the volume of the stone? No, it is the volume of the stone and the water together. I will call this volume V2. I will call the volume V2 is the volume of water plus volume of stone. I still need to measure the volume of the stone only. Okay, so I have to subtract the volume of water from the volume of the stone and water together. I have to subtract the volume of water from the volume of the stone and water together. If I subtract the volume of water, I will get the volume of the stone only. For example, here the V2 volume of water plus volume of stone was 35 cubic centimeters, and V1 volume of water only was 30 cubic centimeters. So the volume of the stone, 35 minus 30, will equal to 5 cubic centimeters. The stone will equal to 5 cubic centimeters. Don't forget to write the measuring unit, which is cubic centimeter. Okay? Let's solve a problem in your school book, page 8, number 6. A graduated cylinder contains 100 cubic centimeters of water. A graduated cylinder here contains 100 cubic centimeters of water. When 4 equal-sized marbles were put in it, I will put inside this cylinder, I will put it equal-sized marbles. 4 equal-sized marbles. The level of water became 120. The level of water became 120 cubic centimeters. Find the volume of each marble. I have to find the volume of only one marble. First, I have to find the volume of all marbles together. Okay? So, we recorded before that the level of water only was, I named it V1. So, V1 equals 100 cubic centimeters. Okay? And V2 equals 120 cubic centimeters. So, volume V of 4 marbles together will be equal to V2 minus V1 equals V2 120 minus 100. It will be equal to 20 cubic centimeters. Is this the volume of one marble, of each marble? No, this is the volume of the 4 marbles together. How can I get only one of them? How can I get only one of them? So, I knew from the problem that the 4 are equal in size. So, I will divide the 20, their volume, on their number, 4. So, the volume of one marble, I will divide their volume 20 over their number 4 the number will be equal 5 cubic centimeter. This is our answer. So if I want to get the volume of only one marble, because the four are same in size, okay, so I can divide their volume on their number.